Thanks for your patience with this. Page 180, looks like about here. Oh, good guess. I hope that was all straightforward. Going down to question 3, domains. Now, you've probably done a bit of work with domains. Just a recap here. A domain is the set. Domain is the set of x values over which the function is defined. Now, you may have done some work on domains last year, and your teacher probably impressed on you how important it was. You'll do more of this year. It's important in the exams, but probably, I guess what I'd say from experience is that it's almost more important in SACs, because often in SACs, we're looking for little ways of splitting students. How can I make student B's result, why is that better than student C's working? Well, if they've treated the domain well, that will improve the quality of their work. You don't always have to do it in an exam if it's not worth marks or it's not required, but in a SAC, it's a way of you elevating your answer. So if you're working with a function and you treat the domain, you elevate your response, increase your SAC scores. So there's a really strong tip for it. If you want to get good SAC scores, get around your domains. So this one here, so we can write this one up. And again, we will accept in the exam, this is an exam type question, we'll accept any correct notation. So in this case here, you can write this answer, and look, our answers go from -2. Be careful, it's from 0 onwards, not 7. 7's a y value. So the x values go from -infinity up to -2, then from 7 onwards. So you can write x less than -2, union x at least 0. You can write that. That will give you full marks for that. You can do that. That's no worries at all. You can just write, but most people, probably from experience, what I see when I mark exams, most people use interval notation because it's pretty simple, okay? So interval notation, you'd write that as from -infinity all the way up to -2, but we don't include -2, so you have a round bracket, and then you go on from 0, and we include 0, so square bracket, off to infinity. We know it's infinity because that bracket's at the end. Now, you can leave your answer like that, or you can write x element of that, just makes that a nicer answer. So this would be the most common correct answer we'd see. If this is an exam question, that's the answer I'd see most of all. Now, if some of you try to do an exclusionary domain, so if you tried to write something like this, all real numbers except, you want to cut this middle bit here out. Be really careful if you do that. You can do it, that's fine, but be aware that the bit you're taking out is from -2 to 0, but notice I've got the brackets the other way around here because I want to exclude the -2. In the actual answer, -2's out, so I've got to exclude it. So when I do real numbers except for, I want to make -2 part of my exception. So I square bracket the -2 and I round bracket the 0 because I want to exclude up to 0, but not including 0. So if this red bit that I'm going to draw is the exclusionary bit, if I'm going to exclude a bit, I'm excluding, if I get a colour, come on, where's my colour? If I'm excluding here, I'm excluding from here through to there. That's why I've got the brackets the way they are. In other words, if that answer is that I've got is correct, however, if you wrote your answer as x is an element of all real numbers except for -2 to 0 like that, you get 0. You don't get 1, you get, or half, 0. There's no half marks in exams, so that would be wrong if you wrote that. First one's correct, but look, again, keep it simple. Keep it simple. That's this one here is the one that most people would write it as. It's the simplest, most obvious answer. So that's the answer to part A. All right. Hope that makes sense. Put the questions up if it doesn't. If not, let's go to question 4. Question 4, time to sketch a graph. Right, we haven't done a sketch yet. I want you to sketch this graph. Let's make this question worth 3 marks, and I'll go through when I do the answer and explain where I'll pay these 3 marks. We'll see if you get all 3, okay? See if you get all 3. Off you go. Put questions up if you're unsure, but keep that going. If you've forgotten what a square root graph looks like, and by the way, we're on page 182. If you forgot what a square root graph looks like, just as a reminder for those who had a really good Christmas and haven't done much work in the meantime, that's what the square root of x looks like. That's the graph of square root of x looks like. It was probably only worth 2. I'll make it 2. That's more realistic. I'll make this 2 marks. Which just means probably a higher threshold for each mark as a result. Okay? So have a go at that while I look at this next question. Good question, Albert. I won't answer that till I do the question, okay? So someone's asked whether we need to state axis-intercepts. I'll let you think about that before I do it. Okay, folks, you're pretty close by now, and I'll give you a bit of a hint and an answer to that question someone asked there. What is required? When you do a graph in a methods exam or in a SAC, what do you have to do? Well, to some extent, you're guided by how many marks we have on offer. If it's only worth 1 mark, we probably don't need much. But a good sort of rule of thumb, I reckon, a good rule of thumb is that if you always include actual intercepts, so x and y intercepts, any asymptotes that are there, and whenever you draw an asymptote, logs, hyperbolas, exponentials, things like that, always include the equation of the asymptote, tan graphs, and endpoints, and always as coordinates. So let's look at this question here. It's a pretty easy graph, but it's more about have you got the detail and all the bits and pieces we need here. So what we have here, you can see over right-hand side there, the basic square root graph looks like that. What's happened here, we've got x plus 1 inside, so that means you're going to translate this graph 1 to the left. So it's a translation 1 unit, the negative x direction. So your graph's going to look something like this. Oops, not like that because I just lost track of my pen. Something like that. So that's the graph. Now, in terms of the shape, so what do you need to do? So if I do that, you might get 1 mark because you've cleared the graph right, you shifted it left. That's probably worth 1 mark. But to get 2 marks, you need a bit more. Okay, you need a bit more to get 2 marks. You should always have the x and y labelled. Okay, will we take a mark off for that this year? Not sure. We might this year. Some years we don't, some years we do. But if you put them on, you can't lose a mark. So get in the habit of putting on right now. Origins, yep, handy. That's okay. But x and y you need. Now I've got this. Now this point here is an end point and a x coordinate. So it's really important. We've moved left 1. It's not hard. Now if you put neg 1 though, that's insufficient. You can't just write neg 1. That's not enough. You need to write the coordinates neg 1, 0. And the y-intercept is 0, 1. Sub x equals 0, and you get y equals square root of 1, which is 1. Okay, don't write this. If you write that instead, you probably won't get the mark for that because we probably expect in exam 1 that you can work out what the square root of 1 is. So it's actually 1, make it 1. And the only other thing about, so that's great. There's 2 marks there. The only thing where you might be in trouble here is if your graph's a bit, if your graph's pretty dodgy. So that's all fine that I've got there, okay? What if it looks like this? If you do your graph like this, you might lose a mark because that's not what a square root graph looks like. That's not good enough, okay? It needs to be a nice, smooth graph. It needs to be a smooth graph that looks like a square root graph. So that's why it's good to use pencil, because if you do that in pen and you say, oh, geez, okay, I better fix that. I'll go like that over the top. That's better. Yeah, okay, now it looks like a square root graph. That's also no good. You can't do your graph like a Viscom shading type thing. It has to be a graph, one nice smooth line, okay? So use pencil for graphs because you can easily rub bits out and redo them, okay? So I'd use pencil for your graphs every time. If you want to go over top with a pen or a highlighter afterwards, fantastic. But as long as your pencil's visible, you're not using like a 5B or 5H or something like that, it should be fine. But there's your graph. The only other thing is the endpoint. Some people draw the endpoint. They think, oh, does it include that or not? Can you square root 0 or not? Not quite. I can't remember if I can square root 0 or not, because that'll depend whether it's a closed-in circle or a open circle. So you can square. The square root of 0 is 0. So that point absolutely does exist. So it's always good to have a nice clear sort of filled in dot in the end there to make it clear to the examiner, I know what I'm doing here. That's definitely a point on the end. I know that. So that's a good answer on the left. One on the right is no good. Okay, so make sure you're right with that sort of thing now. I know it took a long time for an easy graph, but lots of points there that are important about how to get your marks in the exam. Coordinates, endpoints, x-intercepts. Maximum minimums are nice, and if you're asked for them, you need them, but sometimes they're hard to get, so don't do them unless you really need to. You know, if you do a sine graph, you might have 15 maximums in a graph, so you don't want to label every single one of them. All right, that's question 4.